Let's take a closer look at the construction and investigation we began in class today. The question is, can the angle bisector, the median, and the altitude in an isosceles triangle all act as the same line? Now, don't get nervous if you don't know what median and altitude are right now. We mentioned them briefly in class. We will be doing another investigation about them. What we should for certain know is what an angle bisector is. Okay? Know that point D should be the midpoint of AR, and know that KDR or angle ADR should both be 90 degrees. That's really what this investigation is about, seeing if all three of these things can happen at the same time when I draw an angle bisector inside of an isosceles triangle. When we show all of these things to be true, we're going to give ourselves basically another shortcut to use instead of having to prove things in 8, 9, or 10 steps. This shortcut will be called the vertex angle bisector conjecture. So, when I'm told that an angle bisector is bisecting the vertex angle of an isosceles triangle, the question is the bisector also a median and an altitude? So, our first conjecture, and a conjecture is just an educated guess. So if science has the scientific method, geometry and math has proof as a way of showing that an educated guess or a conjecture is true or false. So in dealing with our first conjecture, we're trying to show that the bisector of the vertex angle, so the angle bisector, CD in this case, does divide an isosceles triangle into two congruent triangles. Meaning, if I'm told triangle ABC is isosceles, and I'm told that CD is the bisector of angle C, can I prove triangle ADC is congruent to triangle BDC? This is the same proof that we've been working on for, I'd say, the last 3 days. It should seem very familiar and shouldn't seem daunting at all. The only thing here, though, is that you're actually answering a question with your proof statement, or when you complete this proof. Now, to continue our investigation on the vertex angle bisector conjecture, we are looking to see that if the bisector of the vertex angle in an isosceles triangle, is it also then considered to be perpendicular to the base, or can I call CD an altitude? So, using our same given information, can I show that CD is perpendicular to AB? I know most of us can look at the marking that I made and say, oh, well, yeah, that makes sense. But what do I need to show first in order to be able to say anything about the measures of angle 1 and angle 2? I'm anticipating most of us making it to a specific point with this proof. And my big hint to you is this proof will begin the same exact way that our first proof began. But it's going to end very similar to the way the proof that we worked on in class today ended. So I might have to use at some point, and then ask yourself, what will this reasoning, what will these two corresponding parts that I have proven are congruent, how will they help me finally show this perpendicular relationship at the intersection of CD and AB? Now, problem number 3 and 2 are quite similar. The only difference is that 3 is a story problem and 2 isn't. My given information is the same, and the manner in which, or the ordering of the steps in which I'm going to solve number 3 is going to mirror the order in which I solved number 2. Don't be afraid of 3 just because it's a story problem. If you have any questions, send me a message on Schoology. Good luck.